Our next speaker, Mr. Mike Allen, is security architect at Squirrel. I think he has the privilege of probably being the most energetic, passionate speaker I've seen about Accumulo. I think the last time I saw you speak, you nearly fell off a chair and went through a projection screen. But it's so
these things happen.
It happens. So if nothing else, it'll be eventful. So with that, I turn it over to Mike.
Thanks. Hi, everybody. All right. It's the last talk of the day. Everybody's tired. Everybody, I want you to stand up. Come on, let's stand up. Let's all stand up. Let's all stand up. Come on, come on. Stand up, stand up, stand up, stand up. Up, 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 up. Take a big stretch. Oh, stretch up to the door. Oh, stretch out to the floor. Stretch out to the floor. I'm on the floor. I can't touch my toes. I'm very inflexible. All right, now sit down. Be quiet. I'm going to talk about serious things. Zookeeper's serious. Zookeeper's a key part of Accumulo that no one ever talks about. When you start off programming with Accumulo, you go through this long process of setting up like Hadoop, you've never set that up before. You set up Zookeeper, you've never set that up before. And then finally you set up Accumulo and you can run things and you can do things. You're like, what did I just do? What did I just put on my laptop? I don't know. All right, so we're going to clear up one of those mysteries today, which is Zookeeper. But you'll notice something. When you started programming with Accumulo, I'm sure at some point you installed Accumulo on your laptop. And I'm sure at some point you, like me, closed the lid of your laptop. I'm sure you did. I'm positive you did. Raise your hand if you've ever closed the lid of your laptop while you're programming with Accumulo. Yes. Now, when you open that laptop lid back up and you go and you look at all the things that you just started on your computer, like Zookeeper, like HDFS, like Hadoop's name node, like the data node, like everything else, was everything still up? Was it? Was everything still running? I can't hear you. Sorry, I didn't mean to be that loud. No, it wasn't. What was dead? Accumulo was dead. Accumulo was totally dead. You close your laptop, you open back up, you're like, Hadoop is still running, HDFS isn't a problem child, but you, Accumulo, are a problem child. You went away. Why did you go away? Where did you go? Why? Why did you leave me, Accumulo? You have to start it all up again. You're not sure if you started it again correctly, and you're all confused and unhappy. Why does this happen? Why? Well, let's say we'll figure it out. We'll figure it out. Okay. I don't expect anybody to answer that, and if you know the answer, please be quiet. All right. So, Accumulo, Zookeeper, etc. You know, you draw pictures of this. You draw diagrams. They generally look like something like this, where you have like your worker nodes, and they've got the data node, and they've got the T server running on them, and then you've got your master node running out somewhere else, and you've got the Hadoop main node running somewhere else, and you've also got Yarn, because you've got Yarn because you're running Hadoop too. But you also always have this Zookeeper cluster box, and then no one ever talks about it. Because it's just Zookeeper, it just sits there, it does things, things are happening. I don't know, what does it do? What's in this box? Let's zoom in. All right, that's a little less clear. All right, let's zoom in even more. All right, so we've got, some servers. There's some servers in there. They're talking to each other. There's typically 1 or 3 or sometimes there's 5 servers. They're all talking to each other. What are they doing? So, in essence, what Zookeeper's really trying to do is it's trying to keep state. It's trying to keep state about what the hell's going on inside your cluster. Not just its own cluster, but also about the clients of the Zookeeper cluster. The clients use Zookeeper to help them keep their state consistent. Okay? Zookeeper's good at a very sort of niche set of things. It's good at working with small amounts of data. Do not put gigabytes of data into Zookeeper. It will be very unhappy. It will yell at you. You don't want to be yelled at by Zookeeper. It's very good at keeping this set of small amounts of data consistent across the cluster. Not just its own cluster, which it's also very good at, but across the cluster of machines that are using Zookeeper. Okay, that's what also it's very good at. It's fast. It's relatively fast, especially on reads. Not as fast on writes. Why? Because it's trying to keep a lot of little pieces of data very consistent. And it's trying to keep them so consistent, in fact, it's trying to keep a consistent order of operations. And this actually turns out to be very hard unless you go very slow. So how does it do this? It has this protocol. It's not Paxos. It's a thing called ZAB. They invented it themselves. I'm not pretending to know really much more about it than it's called ZAB, and it does atomic broadcasts across the Zookeeper cluster. Throughout this conversation, by the way, that we're having, which is mostly me talking and you listening, I'm going to say Accumulo cluster when I mean Zookeeper cluster about 40 times. So sorry about that. I'll try and correct myself. So it uses the ZAB protocol between its servers to keep things in a consistent state. Okay? So if you have a system like this, it means that there's some things that would otherwise be really hard that are made relatively more easy because you have a system like this. So what's made relatively easy? Well, you can keep very important pieces of information consistent across a bunch of different servers out there in server land. Okay? And that's what Zookeeper's really good at, and that's what Accumulo uses Zookeeper for. So let's take one of those Zookeeper nodes we saw over here, and let's zoom in. I'm not going to do the same box trick. Okay? But inside there, there's data. And you can think of this data in Zookeeper a lot like you would think of a Unix file system. Okay? There's nodes. Those circles are nodes. I think that's sort of the international standard for a node is just a circle, right? Those nodes have names. Those names look a lot like the names you would see in a Linux or other Unix file system, /accumulo, /instances, /var/boot. Accumulo client, Zookeeper clients can name these nodes whatever they like. You can call them anything you want, and you can put them in whatever hierarchy you want. One difference between Zookeeper nodes and files on a Linux file system is that there's no distinction between directories and files. So any node can hold data. Any node can be the parent of other child nodes. Okay? Simple enough? It's clear as mud, or as much as I've explained it. So there's a couple more interesting things that Zookeeper as a system lets you do with these nodes. One thing is you can store data in them. So you can put any kind of data in there. It could be any data. It's treated as binary data by Zookeeper. Zookeeper doesn't care what you put in there, as long as it's short. I think by default, Zookeeper caps anything you put into a node at about 1 megabyte. Okay, so yeah, when a client connects to Zookeeper, it just makes a connection, to regular old TCP connection to port 2181. It says, hi, here I am, I'm a client. Zookeeper server's like, great, I'm going to give you a random client identity and a random password. When you come back to me with requests, you just send these things back. The client's like, great, I'll send you a keep alive ping, and we'll send it to you every seconds, whatever you configure. What's missing in that interaction that you usually have when you log on to a server? Credentials! That's right! Give that man a gold star. Who's handing out gold stars? There's no gold stars? Ah, disappointed. I should have bought gold stars. Yeah, there's no credentials. Like the client just logged in. It's just like, hey, I'm here. Zookeeper's like, hey, that's cool. I'm going to remember you. Okay? And that's weird, right? That's weird. Like, there's no credentials. It's just like, hey, it's free open space, man. Just come in, check out my nodes. It's all cool. It's like Zookeeper is that weird, cool pastor you had as a kid or something. Hey, check it out. Come on in. Let's get into weird territory. Sorry. But yeah, and then, so yeah, there's no credentials here. That's weird. All right, let's remember that. Let's put a pin in that. Also, this keep alive thing is very interesting because it means that when that client goes away, Zookeeper's going to know, right? It's going to miss that keep alive page. It's going to miss you. Sad Zookeeper's going to miss you. And it's going to know that you went away. That's actually kind of important. And it's actually an interesting feature of the system. One other thing is that when Zookeeper clients lose touch with the Zookeeper server, the Zookeeper library on the client node will also know that. and it will go into various states of disconnectedness, of which there are only 2, and eventually it'll just say, I can't find Zookeeper anymore, I'm out. And it will be very disappointed. But these guys both know on both sides of this conversation if they're still there. So that's sort of an important property. So what can we do with that? Well, one thing we can do with it is we can do this thing called ephemeral nodes. And ephemeral nodes Zookeeper lets clients basically say, hey, I want you to make a node for me. Zookeeper's like, cool. But I only want it to exist for as long as I'm connected to you. Zookeeper's like, great. I know exactly how long that is because you're going to keep pinging me until you go away. All right, so these ephemeral nodes exist until you're gone. And that's interesting. Why is that interesting? Why is that interesting? Well, it's interesting because that means that other parts of the system can tell when certain clients come and certain clients go. Right? Interesting. Okay. Another thing that Zookeeper lets you do is it lets you set up what are called sequential nodes. And what that means is that under a certain node, you can say, I want nodes named foo, and appended to foo, I want a monotonically increasing integer. And no matter how many other clients come in and ask for integer, the next one, only I, as a client, should get, the numbers of next ones. I should never get a duplicate. No one should ever see one client getting 5 and another client getting 5. Like I should get 5 and then another client should get 6, no matter what sort of order they come in or how that all works. And all the nodes in the Zookeeper cluster should agree that 5 went to me and 6 went to that other guy. Okay? That's interesting. This lets you do some interesting things, like you could think about maybe how would I make a mutex out of this that was a mutex that would not only span like just these 2 servers, but like span across an entire cluster of machines. Oh, interesting. Okay. Last interesting trick, Zookeeper clients can put watches onto nodes. So a Zookeeper client can register interest in a node and say, hey, as soon as this node changes, I want you to tell me. If it gets deleted, if its value gets updated, I want to know. And Zookeeper will be all, great, I will totally tell you when that happens. You will know. Watches, though, aren't forever. Nothing's really forever, is it? Sad, but it's true. Watches will trigger once, and then the client will come back. The watch will come back to the client, and the client will have to reset the watch in order for it to continue watching a particular variable. All right, that's interesting. So I can't watch it forever. Another gotcha with that is, oh, wait a minute. The watch will come back, and it'll tell me, hey, the value changed from 10 to 20, or whatever. It'll come back with a new value. But if you want to watch again, there's a little interval there wherein that value might change again. So you as a client can't depend that that value didn't stay 20 between the time you got the watch and the time you re-watched a particular node. So that's just something to watch out for. I didn't even know I was going to make that joke. It's terrible. I'm sorry. There are frameworks that help you interact as a client with Zookeeper. One other thing to sort of point out there is the fact that these watches are happening, and they're happening asynchronously, and they happen at any time, means that the Zookeeper library is doing some threading behind your back, right? That's something to be cognizant of, is that you're attaching to Zookeeper, that means you're kicking off at least one thread, and it's doing something. Mostly just listening to a port. There are frameworks that help you do a lot of this heavy lifting with Zookeeper. Curator is one out of Facebook. It's open source. I recommend you use it rather than you trying to use the raw Zookeeper library. Just makes a lot of things easier. It's got some recipes built into it to do leader elections and other interesting things. Okay, so we're not just interested in Zookeeper in an abstract sense. We're interested about Zookeeper and Accumulo, aren't we? Yes, we are. Okay. Accumulo keeps a ton of data, small amount of a ton, for small measures of time of data in Accumulo. Those are all of the different nodes that Accumulo keeps inside of Zookeeper under that instance node with the long UUID there. So every instance gets a different instance node, and then it keeps all its junk under that. The instances are identified by name over in that instances node over there. Right, so there's a lot of those nodes. We're not going to go through them all, because that would be not only a long time, but probably pretty boring. Because a lot of them are doing some interesting stuff, but interesting to like a couple of Accumulo developers and not sort of widely interesting to a general audience. But the 5 that are sort of in top and are bigger aren't necessarily, don't have more data. That's not size, it's not sort of size of data, but it's what we're going to talk about. So T-servers, the config, tables, root tablet, and user. We'll go through those. So we'll sort of look at what kind of information gets put into Accumulo. So under T-servers, as you might expect, this is a list of the tablet servers that are running in your Accumulo cluster. So how do they know where they all are? This is how. They register themselves inside of Zookeeper when they start up with their host name and their port. And they create an ephemeral lock under that node, and they hold that ephemeral node as sort of a lock for themselves as they start up. And when they die, then that ephemeral node will go away. Okay? So when they are all wondering where they all are, this is how they find it. They go to Zookeeper, they look it up in the T-servers node. Config. So when you start up Accumulo and you're playing around with it, you might set some configuration items from the command line shell. Where do those get written down? If I'd been writing Accumulo from the very beginning, I would have written them down in the file system, and then I would have spent a long time scratching my head saying, how am I going to keep all these different configuration things the same across all these different servers? And then I would have given up, and then I would have used Zookeeper to do exactly that. So anytime you set one of these things, and these are all sort of things that you might set in, say, Accumulo site.xml, if you've played around with that, they all get set up here when you set them from the command line. These values override those that are found in Accumulo site.xml. So if you configure it in here, it's going to take over what's written down in there. Clear as mud? Got it. Okay. Next, tables. When you create a table in Accumulo, the existence of that table is recorded inside of Zookeeper. And it's recorded not by the name of the table, but by the ID of the table, which is a monotonically increasing integer starting with 1, I think. I don't think it starts with 0. Does it start with 0? I wasn't paying attention. That's okay. I am. Anyway, every table gets a different table ID. Under that table ID, they have all these different pieces of configuration information. For instance, if you configure a custom iterator on a given table, that fact that that iterator exists is written down under that conf node right there. That's how that works. Oh, and then there's 2 special tablets. There's 2 special tables up there, plus R and bang 0. Anybody know what those are? Metadata and root tablet. Root tablet, 1 tablet, right? Root tablet, not root table, right? Because the root tablet is special and it gets its own special Zookeeper node. How many people here feel like they understand what the root tablet does and why it's important? Raise your hand. Don't be shy. Come on, show off. Okay, cool. Thanks, Adam. The root tablet is the root of all of the information about where your data is hidden inside of Accumulo when you write it as a key value pair. When you go in to do a scan of an Accumulo table, you're like, I want all the keys from 00 to 100. What actually happens on your client is your client's all, okay, do I know where this tablet is for this table? No, I don't know. Okay. Do I know where the metadata tablet is that covers this table? Nope, don't know that because I just started. All right, do I know where do I have a copy of the root tablet? No, I don't. All right, there's only one root tablet, thus the name root tablet, not root table. It's held by one server in the cluster. That server can change. If that server dies, some other server is going to pick it up. But the location of that root tablet, the location of the server that holds the root tablet, where is that recorded? It's in Zookeeper. It's in fact this Zookeeper node. You can't see my laser pointer because it's not bright enough. Right here it says location. Ding. So when your scanner starts up and it doesn't know anything about anything, the first thing it does is it goes reads that node out of Zookeeper, and it always knows where Zookeeper is because your Zookeeper servers are set in stone when you configure Accumulo. You know where they are. It reads that, and then it goes through the whole process, like contact that server, get the root tablet. From the root tablet, I can find all the metadata tablets, and from there, I can find out where your file is. Okay. Users. All right. So for users, the users are the users that you added from the Accumulo shell. You start off with root when you initialize Accumulo, right? Anytime you do Accumulo init, you're telling it what's the root user's password. A lot of you are going to write secret there because that seems to be the norm for when you're doing development, or password or whatever. But if you create other users because you want to play around with visibility labels and authorizations and figure out how that works, like that information is recorded here inside the users node in Zookeeper. So under the Zookeeper users node, per username, there's a little node, and then what's under there? I forgot. And my slide forgot because it's got a big question mark there. Okay, let's go see. Let's go see if I can do this. Oh, good. All right, good. Oh, it's moving now. All right, whatever. All right, we're going to switch mics. This thing's still on? Good. All right. So if you want to go exploring Zookeeper, you need an interface. And the best interface is not the one I'm about to show you, but it is the one that comes with your Zookeeper. And it's called ZK-CLI. It's also called .sh. I've aliased that in my shell to just be this. All right, the first thing it does is it prints a whole bunch of gobbledygook. I have never once read this gobbledygook, and I never will. It's not important. It should just say, I've connected you. Please go ahead. All right, so now that we're connected, we have a few basic commands. Fortunately, one of them is ls. So you can ls inside of this thing, and you can see what's going on. So / is the root. I've got Accumulo and Zookeeper. Can everybody read that? I can make it bigger. I can't have that technology. Bigger, 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 bigger. All right, that's probably big enough. You can all read that now, right? Yeah, okay, cool. All right, so ls / Accumulo. Fortunately, this shell tab completes. Dink. All right, we've got instances, long UUID. Let's see what's in that long UUID. Oh, look, it's all those nodes that we've just been talking about. Users, blah, 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 blah. All right. What's in users? I have two users. I've got a Squirrel user and I've got a root user because I installed Squirrel because that's who I work for. I work for Squirrel. We make this product called Squirrel. It's not important. All right, so now let's look at that Squirrel users node. Huh? Authentication not valid. Right, just do it. Just, come on, just show me the node. Oh, wait, that's right. Zookeeper has ACLs too. What the frack's going on? All right, Zookeeper has ACLs. Zookeeper does actually protect your data. It's not just a free-for-all in there. But it protects it with these ACLs, and these ACLs are a little weird, especially when you first sort of approach them and you're trying to figure out what the heck is going on. So you can ACL nodes inside of Zookeeper in a few different ways that are built in, and there's some extension thing that I've never played around with. But there's a few different ways. You can ACL them by IP address or subnet, which seems so secure. You can ACL them by host name, so that only people coming from that host, for whatever value of that host you believe as the Zookeeper server, you can ACL it that way. Or you can ACL it using this thing they call digest, which they really should have called username and password, because that's what it means, is a username and password. And you give it a username and a password, and what it does is it creates a digest of that password using probably SHA-1 or some other hash algorithm, and base64ing that result, and then sticking that piece of metadata right next to the node inside of Zookeeper. And then you can set a bunch of different controls on that username and password. You can set whether that username and password should be allowed to create the node, delete it, read it, write it, ACL it in a different way. So that's what that CDRWA piece of business there is all about. Okay? So now that I've ACLed the node, how do I read it? Oh, real quick question. Is there a default way to set them? Like, can I set like a, I don't know, what's the, when you first create nodes, can I set like a default for the node? Not really. Every time you create a node from the API, you're basically saying, I want this ACL, I want this digest, I want this user password, whatever. Yeah, there's no sort of default. To read something that's been ACLed, you need to provide an authentication. The way you do that with the shell is you use the add auth command. You can say add auth digest, because that's what you say. And the user node here, these user nodes are ACLed to a user called Accumulo. These strings here, this word, this Accumulo word here is completely arbitrary. So when you're writing your application, you can make it zab foo bar, whatever you want, right? Someone just made it Accumulo because they were programming Accumulo and they weren't dumb. And then you hit a colon, and then you give it the instance secret, which is what this node is ACLed to. It's ACLed to the instance secret. My instance secret is the super secure default. And then once I've done that, I can read the node. Ta-da! Okay, another neat trick. You can add auth anything you want. Add auth digest zab foo bar colon zab foo bar, and it's fine with it. It's like, okay, you added that auth, congratulations. It might not coordinate with anything that's actually ACLed that way on the server, but you can do it. You can do as many of those as your heart desires, okay? Zookeeper has no notion of like what its users are or anything like that. You do not have to pre-register any of this stuff. You can just ACL it to anything you damn well please. Which is sort of interesting. So like, what if I ACLed it to zabfoobar and then I happened to forget that I gave the password zabfoobar to my auth, right, to that ACL? Well, what you'd find is later you would come back to it and you'd be like, oh, what password did I use? And you would go through all your standard passwords and none of them would work. And then you'd be like, okay, I need to start over. I need to just delete these nodes and just start over, right? Because that's what I want. I want to start over. But I've got other nodes I want to keep, so I don't want to throw away my whole Zookeeper. I just want to delete this node, so let's just go ahead and delete it. Wait. I set the delete ACL. You're stuck. You can't delete it. You can't remove that node without either blowing away your entire Zookeeper sort of instance and recreating it, or just living with that node that's going to be there forever. Unless you have access to the shell script that starts Zookeeper. if you have access to the shell script that starts Zookeeper, if you can write that shell script, you can get yourself out of this tangle. How? Oh, thank you. Thank you very much. By rooting your Zookeeper, you are going to create a root entity inside of Zookeeper. This is very exciting. This is some deep Zookeeper magic that I had to figure out when I ackled some stuff to a bunch of passwords that I didn't remember as I was developing with Zookeeper. The first thing you need to do is you need to create yourself a root user and identity, okay? And the way that Zookeeper really wants these things to be is it wants them to be in that form, that, accumulo : big long hash of a password, okay? So how do I make one of those up? Well, it turns out Zookeeper does provide for you a Java class to do just that. And once you've figured out all of the different libraries that something needs to run that class, you might create yourself a handy shell script that would just let you execute that class with a normal command line parameter. Kind of like the one that's written up there. You all can read that, right? No, no one can read that. I don't want you to read that. Get the slides later. Copy and paste that out of the slides and you'll have yourself a handy shell script. All right, so now you've got that, zkdigest.sh. You can run it with a parameter of like super:secret to set up a hash. It'll tell you, okay, super:secret hashes to super:LKZS75, blah, 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 blah. Okay? All right. Hold that thought. All right, now what do we do? Now we edit zkserver.sh. This is some fun magic here. Okay, so if you happen to have zkserver.sh up in a editor like I do, you would notice that the actual line that launches your Zookeeper is the one in that big blank space there. It's no hup java blah 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 blah, and it's with that handy backslash extend my line over the next line kind of ending there. What you're going to do here is you're going to add in a -d parameter like this. -d Zookeeper digest authentication provider, etc., 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 equals then that zkdigest.sh output, super:, blah, 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 blah. Got it? Yeah, you got it. Because I wrote it down also in the slides, which you can find later. You take this line and you make it that line with the new blue line. Okay? Then reboot Zookeeper, which you would do by zkstop, zkstart. And once you do all that, then you will be able to come back to zkCLI. I'm actually going to quit this one because I already authed into that one. And I'm going to start it again. Clear out all that stuff I never read. And then I'm going to prove that, okay, now I can't read that node again. Accumulo, users, squirrel. Nope, authentication, not valid. I don't know what it is, but I don't care because I can be root. Add auth, digest, super, secret. And ta-da. I can read that node. I can delete it no matter what I ackled it to before. That's it. That's how you root a Zookeeper. All right. Hey, remember this? I was framing the conversation around this. I closed my lid and I opened it back up and my T-server was gone and I was sad, so sad. All right, so why does this happen? Zookeeper, what? My echo was wrong. That was a good guess, David, but not right. No, remember this? All the T-servers are setting up these ephemeral nodes, right? And when the T-server goes away, as it will go away for many minutes, when you close your laptop lid, when you open it back up, Zookeeper is going to be all, I haven't heard from the T-server in an hour. That ephemeral node is toast. Poof. It's gone. When your T-server process comes back up, it's going to receive a notification because it's watching that node that like, oops, your tablet server lock just went away. And your tablet server is going to be all, uh-oh, I don't have the lock. That is not good. What do I do? And what it turns out it decides to do is like, forget it. I'm done. I'm out of here. Brushes its hands. I can't do it because I'm holding the mic. Tup, tup, tup. And it's done. It halts itself. System exit all the way down. No more tablet server. Because it believes that other tablet servers across the network have picked up its work because it's been dead for like an hour. It's been out of communication. From its perspective, it's totally out of touch, and it's just going to die rather than try and do anything clever to recover or come back to life or anything like that. That's why that happens. All right. That's my presentation. I'm happy to answer questions. Yeah? This one? Going back in time. This? Yeah, uh-huh. Oh, to the root tablet. Not to the tablet service, to the root tablet. This one. All right, so the question is, when you're starting an Accumulo scan, and it's going and getting the location of the tablet server, is there a bloom filter involved? And I think the answer is yes, there are bloom filters involved inside of Accumulo. I don't know if they're involved at the root tablet or if they're involved somewhere deeper in the tablet server scan infrastructure. There's a bloom filter in there somewhere. Adam's looking at me smirking like, yeah, that's kind of right, Malin, but I don't think that's exactly right. Because Adam's way smarter than I am. All right, anyway, I'm going to stop doing that. It's probably freaking the microphone guy out. Anyway, so that's the answer to your question. It's somewhere in there. Next, anybody? Yeah?
You said that ZK CLI is a non-agreed shell. Do you have some?
Aha. The question is, ZKLI is not a great shell, which is true. Do I have something that I recommend instead? There is an open source project on GitHub somewhere called something like Zookeeper Shell. I haven't actually grabbed it and downloaded it myself. My colleague John Vides has. He says it works okay. It lets you do things like CD to a node and then do an LS from there. Crazy. No, it's crazy. Yeah. Dave. Oh, web-based UI. That sounds awesome. Why is that not up on GitHub, shared to the world with everyone? It's there. God, send us the link. This thing is terrible. All right. Next thing. Yeah. Your question is, with all these things like Hadoop and Zookeeper and Kafka and now Kafka and Accumulo, and how do you scale out? Like you mean like just be able to process more data? To which the answer is add a lot of servers and then do a lot of tuning because you need to understand how your application works. Or I'm going to answer a different question, which is, should you expect that the number of libraries and servers and other componentry that you need to understand in order to build a really highly scalable big data distributed system is going to ever increase? I think the answer to that is probably yes, but a lot of it will then sort of collapse back as people figure out, well, I've got too many pieces, but all of these could be collapsed in this new thing that I'll build over here, and then people will slowly adopt that. Or do you have a different question? So yeah, the scale of the stuff that you should put in Zookeeper should not be a lot, right? And the stuff that Accumulo puts into Zookeeper is not a lot. It's probably like, if you total it all up and pile it all together, maybe a couple of megs worth of data. It's really not a lot. So that amount of data can exist served very well by 3 or 5 or 7 Zookeeper servers for a big cluster underneath it. Because mostly all it's doing is reading. It's, the ratio is tending a lot more towards reads than it is writes. Oh, that's a really interesting question. So the question is, let me repeat it for the benefit of the general audience. As an application developer, should I be storing metadata in Accumulo or should I store it into Zookeeper? And the answer is, do you want your application to ever work without Accumulo? If you want it to work without Accumulo being running, then you should probably consider storing it in Zookeeper, especially if your application is, highly distributed across the network, kind of an application like Accumulo is. But if you're, pretty highly dependent on the fact that Accumulo exists and is running and in a good state, then storing your metadata in Accumulo makes sense too, because Accumulo will do a really good job of distributing all those reads and all that writing out across a bunch of different servers, a big, probably a much larger set of servers. And it's also going to depend on the, how big is the data, the metadata that you're storing, and how much of it, and how often is it written, and all those kinds of things. So there's a lot of sort of considerations. It's not a sort of binary question. But, there's definitely some mostly read-only data that Squirrel puts into Zookeeper, because all those Squirrel servers need to know about it. Right. The question is, have we done any kind of benchmarking or stress testing with Zookeeper, sort of testing like, how much can it scale, how many reads can it do, et cetera. We haven't done anything sort of specifically targeted towards Zookeeper, like we've never run sort of a Zookeeper-based stress test. We have, scaled our own servers out pretty significantly, and the bottlenecks that we find are usually our own. They're not usually Zookeeper. It hasn't been Zookeeper yet. It would do the same thing. Yeah, if your network goes down, your Zookeeper client and your Zookeeper server will give it a little bit of time, and it's be like, I don't know what's going on. The world is over, right? Especially if the Zookeeper servers become partitioned from each other and they go below a quorum, and they'll be like, I'm done. Okay, so the question is, when you create an Accumulo client, it opens a Zookeeper connection. That connection kind of lives forever. Is there a way to close just that Zookeeper connection? I don't think so. And really, like Accumulo clients will need connections into Zookeepers at off moments, like moments where you're not thinking, oh, I need to give a connection to Zookeeper to this client. So either it would need to, you'd need to give it a callback to say, hey, give me a Zookeeper connection now because I need it, or you let the Accumulo client sort of manage all of that threading and connections for you, which is what happens. The question is, can you watch for new children under a node? I don't know. The answer is yes, says the crowd. I believe them, because I have no evidence to the contrary. But that seems like a natural thing to watch for. Anything else? I've probably run long. Thanks, everyone.